Okay, now we are going to discuss about the next problem. Venturimeter 30 centimeter by 15 centimeter. Remember this 30 centimeter by 15 centimeter is nothing but the inlet diameter D1 will be this and D2 will be this. Okay, so this by is not indicating a box dimension, remember. Okay, venturimeter is provided in a vertical pipeline. Now it is vertical. Previous all the problems are with horizontal, but this is different. That's what I brought you. Okay, so vertical pipeline carrying oil of specific gravity 0.9, flow is being upwards, so the flow is going in the upward direction. This diagram you can see here. Okay, so which is a venturimeter, and the water is flowing in the upward direction. That is shown in the figure. Okay. So the difference in elevation of the throat section and gauge entrance section of the venturimeter is 30 centimeter. So here this is water is flowing in this upward direction, right? So it is considered as inlet, and this is throat. So this inlet to throat, there will be a vertical difference. That difference is 30 centimeter. Okay, this will be used while studying about the Bernoulli's equation. We have seen Z values, right? Z1 and Z2. For that we will difference difference of Z2 minus Z1 will be your 30 centimeter or 0.3 meter. For that we will use this data. Okay, so whilst reading the problem you should understand what kind of data they have given, where it can be used, or what is the purpose of it. If you know that, then you are having the little good idea about this problem. Okay, so venturimeter is 30 centimeter, that difference is 30 centimeter, which is indicated. You can refer this diagram also. The differential U-tube manometer or the mercuric manometer has gauge deflection of 25 centimeter. Yeah, this you can see the difference in mercury level, which is 25 centimeter. Again, this is a manometric reading, that I will note it as X value 25 centimeter. Okay, it is of mercury. Calculate discharge of oil pressure difference. Remember, this is pressure difference, not the pressure head difference. Okay, it is not the H value. Okay, they have looking for the pressure difference P1 and P2. This question they are asking what is P2 and P1 difference, and they are asking about the discharge. They have given CD value, and they have given the mercuric manometer reading. Mercuric manometer reading, as well as they have given the specific gravity of the mercury. These many data they have given. As usual, our procedure, need not to worry. So we have the equation Q is equals to CD into A1 into A2 divided by root of A1 square minus A2 square into root 2GH. This is our equation. In this equation, CD is given, A1 and A2 can be calculated using the D1 D2 diameter. H, yeah, they have given the X value. Using that we will do this. You do carry whichever the way you want, and the things you know. Okay, first you finish the known things. According to me, the given data is to be written as a first step, so I am writing D1 in terms of meter, that is 0.3 meter, D2 that is diameter of the throat, which is 0.15 meter, and specific gravity of the oil, so S0 as 0.9, and Z1 minus Z2, this is Z2 minus Z1. This Z2 minus Z1 value is taken. Z2 minus Z1 is 0.3. Okay, so X value is 25 centimeter. Q they are asking, and H is unknown, and P1 minus P2 we have to calculate. P1 minus P2 is to be question mark. CD they have given. Okay, so as usual, the first step we have to calculate the A1 and A2. So we are calculating A1 using the formula pi d square by 4, A2 using the formula pi d square by 4, but the diameter at inlet is 0.3. According to that, I got the area as 0.7068 meter square, and A2 pi d square by 4. So D I am taking it as the throat diameter 0.15. So I got the answer as 0.0176 meter square. So Q is equals to CD into A1 into A2 divided by root of A1 square minus A2 square into root of 2GH. This is our formula to calculate the discharge through the venturimeter. So in that, H value is unknown for us. So to calculate H value, I have the two equation. I'll write the two of them and I'll select which is suitable for us. X into SH divided by S0 minus 1, and H is equals to X into 1 minus SL divided by S0. So here what happened is the fluid in the U2 manometer is mercury and the fluid in the venturimeter is oil of specific gravity 0.9. So mercuric manometer which is having the higher specific gravity than the fluid flowing in the venturimeter, so I have to use this formula. So I am using this formula to calculate the H value. So and this is used when the U2 manometer is having the lighter liquid than the fluid flowing in the venturimeter. So I will use this when we are using the lighter liquid in the manometer. So currently we are having the heavier liquid in the manometer, so using this formula to calculate H. So H is equals to X into SH divided by S0 minus 1 is equals to 0.25 into 13.6 divided by 0.9 minus 1. So I got the answer as 3.527 meter of oil. Remember, I am using the value meter of oil because the specific gravity is of oil. So I am using the 3.527 meter of oil. Okay, I hope it is clear to you why I am using this term meter of oil. And next is H I got, CD is known, A1 A2 is known. The next step is just direct substitution. So I am going to do the substitution for the equation. Q is equals to CD into A1 into A2 divided by root of A1 square minus A2 square into root of 2GH. So CD is 0.98 and A1 is 0.7068, A2 is 0.0176, A1 square minus A2 square 2GH. So I will substitute all those things, and upon calculation I got the discharge as 0.1481 meter cube per second, which is 148.1 liters per second. Just this conversion is by multiplying 1000 for the meter cube per second value. What I will get the meter cube per second? No, that value is being multiplied by 1000 to get liters per second. Okay, because 1 meter cube is equals to 1000 liter. So the first part of the question, the Q value I got. Okay, so they have asked second part, calculate the pressure difference. So they are asking for us to calculate the pressure difference, right? So to pressure difference is to be calculated using this relation. Okay, this relation I am writing because in the previous case I was not using Z1 and Z2 because in the horizontal case Z1 is equals to Z2, so I was not using. But here what happened is it is vertical manner, so Z1 will not be equal to the Z2 when it is vertical. Okay, so it will be having the difference Z2 minus Z1, we have the difference as 30 centimeter. Okay, so I am using this. If we have the horizontal, then P1 by rho g minus P2 by rho g is enough. When it is in the vertical case, then we have to take P1 by rho g plus Z1 minus P2 by rho g plus Z2. So I will segregate the terms of P1 and P2, Z1 and Z2. So P1 by rho g minus P2 by rho g plus Z1 minus Z2. I will take actually I have to calculate P1 minus P2 value, right? So I will take these things into one side and these things into other side. So unknown will be on the left side and known things will be on the right side. So I am sending this Z values into that side. So H plus Z2 minus Z1. So now I got the term as reverse, H plus Z2 minus Z1. So which implies H plus Z2 minus Z1 is equal to P1 minus P2 whole divided by rho g. As it is having the common base, so I have taken rho g as the common base. Okay, so next is the substitution. H value I got 3.527. and Z2 minus Z1, which is I got it from the manometer, that vertical difference is there, no, that 0.3 meter or 30 centimeter, that is I am substituting Z2 minus Z1 into rho g is equals to P1 minus P2. This rho g is being sent to this side, so I got it as multiplication for this. Actually I need to have P1 minus P2 value, so I am going to substitute this 3.527 plus 0.3 will be 3.827 into rho. This rho value is not the water, it is oil of specific gravity 0.9, so I have to substitute that rho value, 1000 into 0.9 I have to multiply to get the specific density of the oil, so it will be 900 into 9.81 as usual g. So from this I got the P1 minus P2 as 33,788.58 Newton per meter square. So this is what P1 minus P2, and Q I got it as 148.1 liters per second. So this is the answer for the both the cases. Okay, I hope it is understood to you. If it is required, I will repeat once again. You just have the overview. They have given D1, D2. They have given pressure. They are asking us to calculate the pressure difference and discharge, but they have given the differential manometer reading, and then they have given that difference in the level of the inlet and throat. This much of ideas they are given along with CD value. So using D1 and D2, I am calculating using D1 and D2, I am calculating A1 as well as A2. So once I got the A1 and A2, I am going to calculate H. So this is required is because when we are seeing the discharge equation, that is Q is equals to CD into A1 into A2 divided by root of A1 square minus A2 square into root 2GH. We have the requirement of H value. So I don't know the H value, right? So to calculate H value, I have the two formulas, but it is dependent on the mercuric liquid, either heavier or lighter. But in this case, it is heavier liquid in the manometer. From that, I got it as this equation, H is equals to X into SH divided by S0 minus 1, and from that I got the answer as 3.527 meter of oil, remember. Okay, so next I substitute in the Q, and I will get the Q value as 0.1481 meter cube per second and 148.1 liters per second. Okay, next part is calculating the P1 minus P2 value. Actually, H is equals to P1 by rho g minus P2 by rho g when the venturimeter is in horizontal direction, because Z1 is equals to Z2. But here what happened is venturimeter is in vertical direction, so Z1 will not be equal to Z2. So here it is having Z2 minus Z1 is equals to 30 centimeter. So for that I will use the terms P1 by rho g plus Z1 minus P2 by rho g plus Z2. What is P1 by rho g and P2 by rho g is unknown for us. So actually we have to calculate P1 minus P2 value. Z2 minus Z1 is known, but here we have Z1 and Z2. Let us see what we have to do. H is equals to this and this, right? What I do is I will send Z terms into one side and unknown terms, that P1, P2 terms into another side. From this I got H plus Z2 minus Z1 is equals to P1 minus P2 by rho g, which is 3.527 plus 0.3 into rho g is equals to P1 minus P2. Then P1 minus P2 I am getting it as 33,788.58 Newton per meter square. Okay.